Hello guys, welcome back to my channel. This is Deepak Kumar, and today we are going to discuss question number 153, find minimum in rotated sorted array. This is today's daily question. So let's get started. In this question, we are given an array of length n, which is sorted and then rotated k times. However, we don't know how many times it is rotated. Like in this example, we are given an array which starts from 0 and goes to 7, and then it was rotated 7 times. Similarly, in this example, it starts from 1, ends to 5, and then rotated 3 times. And here in this question, we have to return the smallest number in that array. But the thing is, we have to write an algorithm that runs in O log n time. So we are going to discuss our most optimized approach, which will be on O log n time complexity. But before that, let's try on for some normal time complexity, which is n. So let's move to the whiteboard. Now here we will discuss our approach. Let's say my array is 3, 4, 5, 6, 1, 2. Now here my minimum will be 1. So what can we do? My first approach will be a loop where we will compare two numbers and store the minimum one. By this process, we will run the loop n time, giving us O log n time complexity. We can also My second approach will be minimum element in STL container. It will also give us the time complexity of n of on. Now let's talk about our most optimized approach. Here we are going to use binary search. As we know, in binary search, the array must be sorted. And here we are given that no number is repeated. And before rotation, it was sorted too, which means after the last number, either first number will be the smallest or greater than the last number. Like in example of nums, which I had given earlier, 3, 4, 5, 6, 1, 2. Here, after, there are two cases. Either 2 is the greatest or 3 is greater than 2. We are going to use this for our process. So what will be my approach? Here, what we will do is to calculate the mid element, mid index. Then we will check if my nums of mid is greater than nums of right or not. If it is, which means like here in example, my will be 5, which is greater than 2, then it seems that my smallest element will be in the right because the left element is greater and they will so the sudden jump will be on its right. So I can say that I will update the left as mid plus 1. If not, then I can update the right as mid. But why mid? Let's say for an example, uh, nums equals 1, 2, 3, 4. Here mid will be 2. Sorry, mid will be 1, which means nums of mid will be 2, which is less than right, but greater than left, which means my second will be followed. second condition will be followed. And here I have to update the right as 2. But why we are doing this? When my this condition is false, which is num mid is greater than num right, then we are updating right to mid. This is because I we can't say for sure that my mid cannot be small. Let me tell you for an example. Here, when after some loop, some iteration, my array will become 6 comma 1 comma 2. Then after another iteration, it will become 6 comma 1. Here mid was 1, so I have to keep 1 in the array because it is the smallest one. So we are using right to mid. And now when my left and mid and right will be equal, we are going to return the nums of left. But why so? As at some point of the loop at iteration, my nums and right nums of left and nums of right will be stuck at 1. We'll use that point to secure our smallest number. Like let me give you an trial example. Here my nums was first 3, 4, 5, 6, 0, 1, 2. Then my left is 0, right is going to be my 5, 6. Then my mid will become 3, which means my nums of mid will be 6, which is greater than my nums of right. Then what we will do, you can see, we will update the left as mid plus 1. The mid, my mid was 3, so my left will be 4. Now, my we are calculating mid again, which will be now this time 4 plus 6, 10 by 2 will be 5. Then my nums of mid is 1, which is greater than nums of left. So my right will become mid. And now left is my 4, right is 5. So mid will be 4 again. As 4 plus 5 is 9 by 2 will be 4. We are using integer for mid. And now nums of left is smaller than or equals to nums of mid, which will fall here. So what we are going to do, right equals mid. And now since my left and right are equal, which is here 4, we have the smallest number 0 at index 4. And this is our answer. Now, as you can see, we have solved this question in just a 3 to 4 iterations. Instead of going for all 7, this question is solved in index in the time complexity of log n. So let's write the code. But before that, we will write these two first and we'll see if these two works or not. So let's go. We will use int minimum equals to min element. Now we will return minimum. Now some of you might think what the star is doing here. Now since the main element is a SQL type iterator, it returns an iteration value and not the number. So we are using dereferencing here to get the smallest number. Let's try the running the cases. You can see all the test cases have been cleared. So let's try submit this one. You can see all the test cases have been cleared, but this one runs on a O of and time complexity. So now let's go for the most basic approach, which is using a for loop. What I'm doing here is if my nums of I is greater than my nums of I plus 1, then we are returning that nums of I plus 1. What is happening here? Let's say an example, this one. If my here 4 is not smaller than 5, sorry, 4 is not greater than 5. Here 5 is not greater than 6, 6 is not greater than 7, and 0 is not greater than 1, and 1 is not greater than 2, which means there is only one case left, which is 7 is greater than 0. And this will happen only once because all the numbers here are unique. But now there can be some cases, something like this one, where first number is smallest. Here the thing is no left number is greater than right one. So here what we will do, we will just return nums of 0. So now let's try this one too. You can see all the test cases have been cleared. Now let's try submit this one. You can see all the test cases have been cleared here too. This one too runs on O of n time complexity, which is not the most optimized approach. So let's move on to the optimized one. Here what we are going to do is to declare three variables, my left, my right, and my mid. Now what we are going to do is to start a while loop where my left is less than right. Here we will calculate mid. We will check if condition, if my nums of mid is greater than nums of right, then what we will do is to update left. If not, then what we will do is to update right as mid. Now here we are going to return the nums of left as we have shown you in the whiteboard. As at that time my left and right will be on the same page. Now let's try running the code. You can see all the test cases given in the LeetCode have been cleared. Although we can also write it in another form, which will be something like we are using left equals right. Then we are comparing if my left and right are equal, then returning nums of left. Basically, these two are same thing. Just here, what we are doing is to compare it till when left and right are equal, and then if it is so, then we are returning it. And in this one, we let it till compare till left and right becomes equal, and whenever it becomes equal, it just breaks itself and then returns. And in this one, it is just for dummy because in if condition we cannot return. If we do, then the LeetCode will throw error because it requires a surety of return in these questions. So let's try submitting the question. As you can see, all the test cases here have been cleared. So this is the most optimized approach, which goes on O of log n time complexity, which is the most optimized approach in this question. This is all for today. If you liked our approach, then please like the video, subscribe the channel, share the video, and comment below down your thoughts below. Solution link will be in comment section. Thanks for watching.